Okay, so let's walk through our study guide for exam two. All right. So we went through this in class today, but I wanted, as I said, wanted to go through and record it, maybe elaborate a little bit more on or embellish on some of the concepts here, just to try to reinforce this as you're preparing for the exam. All right. So as you said, exam two is going to be all about databases, relational databases, and the concepts and the terms we that are associated with that. All right. So the first area to take a look at is what kind of go back and review what we mean by the normalization of data, and then what is the minimal usable form of a database. So this goes back to the rules that Cott established when he was creating, when he was developing the relational database theory, that in order for this stuff to work, you have to structure the data a certain way. At a minimum, the minimum usable form for a relational database is the third normal form. You will see third or fourth normal form. Most databases usually do not go out to the highest level, the seventh level. I mean, from a practical purposes, third and fourth normal form usually are good enough to work. All right. We talked a bit about this idea of, when we look at a databases, there's really two different perspectives we can look at it as. One is this idea of the logical design of a database, which is really, the tables and the connections and the keys and all that stuff. All right, those are all logical constructs. All right, so it works for us, from our perspectives as we're designing and using these things. We can kind of hold these abstract objects in our minds, and then the physical implementation is actually how we store it on the computer. So ultimately, it's stored, on some sort of permanent um, storage, on a disk somewhere. But from our perspective, from an end user perspective, we really don't care. All right. And what happens is the database management system, which is the software that sits in between us and the physical representation of the database, is what handles all of this translation. So it knows what we're asking for from the logical side of things, and can translate that into the physical representation, and then be able to pass data back and forth. A bit more detailed normalization. If you want a formal definition, it's streamlining complex groupings of data to minimize redundant data elements and awkward many-to-many relationships. So it's really a way of streamlining the data such that we can access it, that we can access the data, ask questions of the data, analyze the data, and the results we get back will be correct. Right. Referential integrity, which is a set of rules about databases. Another rule database basically says that between any two tables, we can have a relationship. All right. However, that data, so all that really means is there's a common field. There's something common between those two tables that we can use to link the two together. Referential integrity means that all of these relationships, all the data in the first table and the second table, it's all consistent. So there's not any missing pieces or parts, because what will happen is if there's missing pieces or parts, then potentially when we ask a query, we will not get it. We will get an incorrect answer. You want to take a look at the different types of databases, but in particular, relational databases, because relational databases is the mainstream model that is used by most companies. All right, you'll see things like hierarchical. We talked about hierarchical and object and network, and there's a whole bunch of them. But the one that really is the most important and the one that you want to know about is the relational databases, which is what we had talked about with the tables and joins and queries and all that stuff. Alrighty. So you also want to go back, take a look at the access data, like our sample access database, and take a look at some of the queries we had built, because we had done that whole exercise where we created our database and then we created a query. We created a single query to pull all the tables back, reconstruct the database. All right. So what you will see on the exam will probably be a couple questions in which you'll get a sample database, a sample query, and it'll ask you to play the database. So you'll get to play the database management system. So you look at the data, you look at the query, and then you'll come back with the results. So say, for example, if there's a query out there that says something along the lines of find all things that are equal to or greater than a number, then what you would do is count everything in the table that is greater than that number. All right, that's kind of how we would process it. So basically, you're going to pretend that you're the database management system. All right. Want to review the following terms. So take a look at these. Some of the be comfortable with these terms, kind of the organization of this stuff. So a database, we define a database as being a group of related files, collection of related files. A file is a group of records, similar records of the same type. A record is a group of fields, a group of related fields, and then a field is a group of characters, such as words or numbers. All right. Database management systems. We talked a little bit. Some of the key facts that you want to keep in mind is, it's a piece of software that sits between the end user and the physical databases in the files, and really serves as the communication from between person and machine. It interfaces between applications in the physical data files. It separates and can understand both the logical structure of the data and the physical views of the data, right? and handles that for us. And finally, it is, what it's designed to do is to fix, the some of the traditional problems we have with file-based applications. So the idea, there's nothing that in a file system would keep us from, creating redundancy, duplicate copies of things or multiple copies of things, inconsistency, the dependence between programs and data. So, so one-to-one correspondence with the database. A database can be used by many different types of programs. All right. And then, it has the ability to centrally manage all of the data and, provide security for it, which is something that is, we really don't have with the traditional file system necessarily. All right. Some other concepts around relational databases you want to take a look at. Number one, it's derived from relational algebra. Not relational calculus, not linear algebra, not other things. Relational algebra represents data as two-dimensional tables. Each table contains data on what we call the entity and the attributes. Right, and the table is represented as a grid of columns and rows. All right, so you think about a table as being, kind of looks like a single spreadsheet. A table can be seen as sort of like a single spreadsheet. All right, so it's a grid of columns and rows. All right, the rows are, the records. We would say the rows of a table. Records for different entities. As we say, different entities or different data we collect. The fields can also be called columns. All right, and that represents that represents what we call the attributes. So the terms field, columns, and attributes basically mean the same thing, all right, depending upon how you use it. All right, attributes goes back to the kind of the relational core of relational databases. Fields are from a kind of describes it from a technical perspective, and then column is actually kind of more closely aligned with the database, kind of database and database designers. Right? But all three are really kind of talking about the same thing. Right? A key field is the field that we use to uniquely identify each record. All right, so there is one field that has to be unique in every record. All right, and we call that key the key field. There is the primary key field, which is the one that that is the one field that we have tagged as being the one value that is unique in that record. And we can either find a field in the table and assign it, or we can just simply create just a placeholder, just a fake key, with the numbers 0, 1, 2, 3, 4, 5, so on and so forth. The foreign key, on the other hand, is the key in the other table. So if I'm going to hook two tables together, I have a key in the first table, and then I have what we call the foreign key in the second table. They're basically the same data. It's in the foreign key and in the primary in the primary table, and in the second table, the foreign key. It's the common field that we use to tie things together. We call it the primary key, used in the second table as a lookup field to identify records from the original table. It's how we connect two things together. All right. The two basic operations that we use in a database. One is the select, and what it is, what it will do. It's a command where we give instructions, and what it will do is it will create a subset of data for all of the records that meet a particular criteria. Okay, so what will happen is I will say select, from a table all fields where the name of this, the last name of the user, assuming there's a field in there called user, the field is like a F star. All right, and what that will do is that will do a lookup of, that will find all records in that table where the field, where the letter of the user begins with the letter F. Right? Or I can say it's equal to something, or greater than, or less than, and I can combine multiple. I can put multiple logical rules in there. So I can say it can be this and this and this. I can put multiple fields, and I can also have an or. So an or condition is it will take everything we say, this and this and this and this, and that's one set. Or then I have another set, this and this and this and this, or this and this and this and this. All right, so each one is totally separate, firewalled off. When I have a selection criteria for a query, if I say select something, I can say, give me everything that has this and this and this and this, or another set, or another set. All right, so that is that, and then a join. The other concept we have, and both of these, both selection joins are driven, or you can find kind of the foundations of it in in relational theory. A join is what we do in order to connect two tables together in a relational database. All right, across the common field. All right, so we have the foreign key. We use the foreign key in the table to tie the two tables together. All right, and when we tie the two tables together, we can get any data. We can get all the data that is, in that, on the records that match. So if you can imagine, it creates, if I tack three tables together, everything it matches, I can get all the data that's in that. Of course, in all three of those all three of those tables. And as we said, when we execute these basic operations, if I do a select and or joins, the result of what I get, the output, is something we call the result set. So relational theory is based on sets. Set 1 plus set 2, or the intersection between two sets, so the difference between two sets. So what we do is if I join two tables together, or even if I just query a single table, I do a select against the single table. What I get when I get the results, we call that the result set. All right, and what it is whatever the outcome of our query is. All right, so what will happen is I can put as many fields as whatever comes back between, say, for example, if I join two tables together, if I find something that matches my criteria, I can then bring everything, all the fields that are in both those tables can possibly be brought back and put into the result set. All right, so a result set looks like a table. Actually, to some degree, it kind of has the characteristics of a table, but it's not a table. All right, and when we do these selects and we do joins, we don't touch the structure of the tables. All we're doing is we're reading them. All right, and putting the output or doing whatever we discover at the end or whatever we work on at the end. That's what goes into this result set. All right. And then we talked about how databases are different than spreadsheets. Databases are built around the concept of rules. All right, so before you can do anything with a database, you have to figure out the structure of it. You have to define the rules for it. All right, and once you create the rules, then you construct the data and then load the data. All right, so there's a fair amount of upfront work that has to be done, to develop and enforce the rules that goes into a database. Spreadsheets, on the other hand, are much more flexible. All right, so you can just load data into it and start playing around with it. All right, so databases, as we said, databases are not exactly the same. There's some similarity, there's some functionality, especially what we had talked about with some of the new features that are in Excel around tables and pivot tables and filters. All right, which give it a database-like capability. All right, it's not it actually works. Spreadsheets are not based upon the relational theories. All right, and then one of the things about the relational model, kind of from what we've been looking at are fairly small databases. So when you look at a small database and you look at a spreadsheet, sometimes you just simply think, well, it's easier to work with a spreadsheet. All right, the advantages that databases have is that they scale massively. So what happens is, I can easily create databases with millions of rows. All right. Whereas with a spreadsheet, I can work with, hundreds of rows, maybe a couple thousands of rows. But as a spreadsheet gets larger and larger, it becomes more unwieldy. All right. So another key difference is really the scalability of databases are much higher than with spreadsheets. All right. So let's take a look. So one of the other things I had said is you want to do is take a look at the quiz. So let's actually go back and look at the quiz. We'll actually walk through it. All right. So this is quiz 2. All right. So we talked about kind of our questions on this one. So the first question was, what is this? I guess hang on a second. It didn't show the question. Okay. All right. So what we have here is, oh, here it is. Listed below is an example of. All right. So what this is an example of a table. All right. It's a table. All right. So the records are the individual, each line in the table would represent a record. All right. A file would be, this table would sit inside of a file, but I could put multiple tables can be stored within a file. All right. And then the fields are the individual, or as we call them, the columns or the attributes here. So agent ID and office ID and agent commission. These are the fields. All right. So the answer for the first one is a table. Databases and spreadsheet operate pretty much the same. That is false. All right, they really don't operate pretty much the same. As we said, databases are, really built around a structure where we have rules and things have to be done in advance, whereas spreadsheets have much more flexibility. Databases scale much larger than spreadsheets. Databases are built upon relational algebra, so those are some of the differences between them. So they don't operate pretty much the same way. If you look at Excel and Access, yeah, they kind of look the same because they both come from Microsoft and they're both part of Microsoft Office. All right. So third question, streamlining complex groupings of data to minimize redundant data elements and awkward many-to-many relationships. That is what we call normalization. All right. So referential integrity refers to, the rules that mean that the different the keys, the foreign keys across different tables have to remain consistent in order for the database to work properly. All right, so that's a set of rules that make sure that we maintain and sustain the integrity of the database. Entity relationship diagram is a picture of what the database looks like, and then querying is running a query and executing it. All right, so this one is normalization. So for 4, looking at the data below, what field would be the primary key? So we'll give a hint here. It's not always the first field, and it's a value that makes the record unique. So this is a little, if we look at this, so you could say, theoretically, we could say the selling agent could be the first name, or could be a key, assuming that everybody's unique. Everybody has a different name. But the real answer, if you look at this, the real answer is really the agent ID. All right. So because that really is just a number we're assigning. I could have more than one agent with the same name. But if I if I put a number for an agent ID, I can ensure that would be unique. So as we said, the hint is it's not always the first field in the record, and it's a value that makes the record unique. So, but it's also not, it does not have to be, like I said, this one is actually like 3 or 4 fields in. So long as it makes it unique, it could be anywhere in the record. All right. So as we said, the correct answer is agent ID, which is this last column here. All right. Question 5, match a term with its definition. This one takes a little bit of thinking, so let's take a look at this one. All right. So databases are, it's a collection of related files. That's what we call a database. A file is a collection of records of the same type. All right, so you think of this as a hierarchy. Databases are at the top, file is next, record is a group of related fields. And then a field is a group of characters, like a word or a number. An entity is, a person, place, or thing that on which we store information. So it's kind of, the term gets used, kind of interchangeably with tables. All right. And then an attribute, which also, as we said, can be kind of used interchangeably with field, is a characteristic or quality describing an entity or a field. All right. So number 6, we said, what's the process of using criteria on data to get a specific result? And that is querying. Right? This is, it's, we write a query. We write a query to get an answer. So we write a query, we give it to the database management system. It reads the query, figures out what we're asking for, goes to the database, actually goes to the data in the database, executes the question, gets an answer, and then returns it back to us. All right. Primary key, referential integrity. We talked about what a primary key is. I think it makes a record unique. Referential integrity, basically the consistency, making sure that all of the data that describe the relationships between tables is correct. And then foreign key is the field we identify, in a table that we can match. We can match the two tables on. All right. So 7, we said a join is described as a connection between two tables using a common field called a foreign key. And that is very true. Right? That's the definition of what a join is. This view describes the way users look at construction and structure of tables in a database, and it is managed by the database management system. Right? And that is the logical view of the database. All right, so remember, that's the people view. So logical views are the people's view, are the way we see it. All right. Conversely, the view that describes the way the data is actually stored in the database and is managed by the database management software is the physical view. All right. From our perspective, we don't care what the physical view is. If you're asking the question, you don't really care so much where the data is coming from, so long as the answer we get back is correct. All right. But the physical location of things actually is important around performance, and there's a whole art form around how you construct a database from the technical side of things to be able to get good performance and correct results at the same time. All right. And then finally, we said the view that can be used to view data in a table in Access. And that is the Datasheet View. Right? So the Datasheet View, what it actually does is, if we write a query, or if we look at a table, or if we look at a query of a table, if we say look at the Datasheet View, it gives us the results of what the query is. So it shows us all the data that's in the table, or what we get back from after a query executes. The design view is the logical view of the query that we're developing. All right. So, Access actually has, for when we're creating like a query, we can see it as a datasheet view, which will give us basically a list of the data. We can see in the design view, where we'll have multiple tables, and how these things are joined together and connected, and what we want to be able to return, put into our result set. The SQL view is the actual SQL that we get, from the design view. All right. As we said, the SQL view is the actual SQL commands which actually get executed. All right. So the QBE is that were used with the design view is kind of our way of being able to look at the stuff logically, which then is translated into a set of SQL commands, which are then passed to the database management system to get our answers. And then finally, a form view is actually related to stuff we didn't really talk about in Access, but it's Access has a whole bunch of capabilities that actually lets us develop screens and layouts and stuff like that. So that's what a form view is. But for the question of the view that can be used to view data in a table in Access, that is the Datasheet View. Okay, and I think that is about it. All right, so so basically we walked through the sheets, and I actually walked through the quiz, in detail. All right. So if any questions, just get back to me, and we'll, just board them along, and I'll try to get back to you as quickly as I can. All right. Thanks a lot. Talk to you soon.